and welcome back to the RTIP series. Today we'll be talking about how to anonymize data using R and some RECON packages, especially one called epitrix. So without further ado, let's have a look at this folder that I've created for you, anonymized data, in which I have a line list, which is just a toy example data I've made up to look like a teeny tiny line list, but basically something that should be familiar if you've been looking at outbreaks before. So you've got a flat file, an Excel spreadsheet, in which you've got a bunch of variables in columns, and every row is a different individual. And so what do you have there? Well, you've got first name, last names, date of birth, genders, and a few dates and symptoms being recorded. So typically that's a kind of data that you'd get from the field, but when you're going to have to share these data more widely with people who will look at data, you'll have to typically anonymize this kind of data. That is, this information can identify individuals, and you don't want that. So what do you want to do? Well, basically you want to use some of these fields, such as first name, last name, and maybe date of birth and gender, that are sufficient to uniquely identify individuals, and then turn these into anonymized labels, which will basically mean nothing and won't be able to be used to identify people, but that will still identify the same individual across different data sets. So how do we do this? Well, the first thing we're going to do is start our session. So in this folder, I've created a small R file, which I'm going to open in RStudio. And this is mostly for me to remember what I'm supposed to tell you about. Okay, so I've got a few commands in there already telling me what to do. The first thing that we want to do here is going to be to install the package we need. So I just want to make sure that you've got the right version of the package, because this is actually using a version that I just put on CRAN as of yesterday. It's been submitted into CRAN, so we may need to just double check and install it. So what I'm going to do here is effectively install the GitHub version of the package. We've seen that in the last video, how to install packages from GitHub. So install _ GitHub, right? And the package you want to use is on RECON Hub, which is the hub on GitHub for RECON Hub / epitrix, which is essentially a bunch of tricks for epidemics analysis. So this command line here is going to install all of this. I'm going to save it there. Right, it's all installed. That's brilliant. And I'm going to say library of epitrix. And yes, and that should work. And I'm doing things the wrong way around here. I should probably start like type here and then basically send it to the console. Okay, so I have this package that is now loaded, and I can double check. It's probably in there as well. It will tell me the version of the package is 0.1.2, which is the right version. 0.1.1 doesn't have exactly the features we're going to be using here. So you want to make sure you are using at least this version here. Right, so the next thing we're going to need to do is basically import the data. So if you're in base R, there's a bunch of ways you can import files from an Excel spreadsheet. The simplest one probably is to save it as a CSV file and then use read.csv. But in this case, because we're using RStudio, it's even simpler. So what I'm going to do is click on File, Import Dataset from Excel here, and it should all work nicely, hopefully. Let's have a look. Browse. I'm going to have to pick the line list, which is here, which is great. Open. Let's have a look. The good thing here is that it actually tells you which command line are being used here. So you could just copy paste this as well, which actually I am going to do because I want to add this to the script later. So okay, I'll add it to the script after that. Okay, so I've got my file here. It looks all fine except for these here. The dates are stored as double, that is as like double precision float numbers. What I want here are dates. So I'm just going to indicate these are dates to make sure they are stored as dates, even though for the purpose of anonymizing the data, it won't really matter too much. Okay, it's all good. Import. I will update this command line here. Control C. Okay, import. And there we go. I've got my line list that's been opened here. I will go back to my script. Can I actually copy paste this here? Yes, that's great. Okay, good. So this command line has been saved. Can probably just do this here. I don't know how to indent automatically. You can tell I'm not familiar with this text editor. I use Emacs most of the time. Well, okay, that won't take forever. All right, that should be it for now. Good. So I've got a new object in R called line list. And if I type line list here, return, you'll see, let's have a bit more space here. Okay, I've got everything here. The readxl package that we've been using is effectively importing data as a tibble, which is some kind of fancier version of a data frame, which is a bit more user-friendly to visualize. But like basically, if you're used to data frames, this is the tidyverse version of a data frame. Nothing is tremendously complicated here. So you have the first names, last names here, and dates of birth, gender, etc., etc., etc. There's another few variables that are not being displayed here, but it's telling you which variables are not being shown, just for like space purposes. Right, so how do we anonymize these data? Well, the first thing we're going to need to do to anonymize the data is decide which field we're using, and then I need to show you which function we're using for that. So in terms of field, if I want to say access the first name here, the first column, I can just do line list $ and the name of the column, and that will return basically the first names. Okay, so that's the first way to access this explicitly via name. Otherwise, I could use a square bracket operator and say I want all the rows, so nothing here, comma, the columns that I want to retain, in this case the first one, and there we go, I have the first column isolated here. Okay, so this is how I will select the fields I want to use for to design the labels and then anonymize them. Now, what function am I going to be using for that, for the anonymizing the data? So the function itself is part of epitrix. I'm going to say library. No, it's been loaded already, and it's called hash names. Okay, completes already automatically. Let's have a look at the documentation of this. Okay, right. So, anonymize data using SHA-1. So what does it mean and what's SHA-1? So SHA-1 is basically a hashing algorithm which is meant to be fairly secured, which is not the most secure you could use, but it's good enough for the purpose that we are going to have today. So what is a hashing algorithm in the first place? So a hashing algorithm basically is a function used in cryptography typically, which is meant to map an input into an output in such a way that this mapping is deterministic and that it's not, you can't trace it back. So what do I mean by that? So deterministic means every time you have the same input, the hash key will be always the same thing. And the hash key is essentially going to be a long string of characters and numbers. Okay, which has been determined from your input. So you take a complicated input, pass it through your hashing algorithm, your hashing function, and you will get numbers and characters back from that. The other, and that's deterministic, so you always get the same thing. The second important thing here is that you can't trace it back. So when you have the hash key, it's virtually impossible to determine what the input was. To do that, you basically have to use a hacking technique called rainbow table, which essentially is a pre-computed table of all the possible hashes for all the possible inputs you could think of. So you can see already that this is going to be difficult. We'll come back to rainbow tables and how to avoid that kind of hack towards the end of this video. So first thing first, let's have a look at this function here. Okay, so the function is called hash name, and then it takes an argument called ... which is essentially any number of arguments, any number of fields you want to use for the hashing. So if I use hash name of let's say line list $first name, let's use just the first name for now, this is what I get, okay? So here you have a data frame that is returned back, and you have the label as it's been processed. You can tell that everything's been put to lowercase. There's another bunch of changes are made, like all accentuated characters are replaced by the closest match in the Latin alphabet and so on and so forth. So different ways to basically simplify the input labels. So you've got your input labels here, and here you have two types of hashes. The last one, the long one here, is the full hash of produced by the SHA-1 algorithm, while the short here is just a shorter version, which typically is enough to ensure that these hashes are unique. That is, there's no chances that with the two different inputs I will have the same output. And the arguments here, so I'll encourage you to look at the documentation here, but the size here is basically the size for the short hash. Okay, so you could have like slightly longer ones if you wanted to. Right, so this is basically what happens when I use the first name and the last name. And you can tell that there's been a few interesting things here. If I go back to the original line list, you will see that there's been some oddities in this line list, and these oddities I'm going to use to illustrate different points here. So the first one is that some individuals here, you can tell that there are two Joses and two Johns, okay, which is going to be a problem because obviously, again, it is deterministic. For the same input, I always get the same output. You can tell that the hash key here is the same as here, and the same for John here has the same hash key as here, right? So how do you go about this? Well, the first thing is don't use just the first name. Typically, to identify individuals, you need a first name and a last name at least. You may want to append their gender or date of birth onto it. So let's just recall this command line here, and I'm going to add the second column, which is line list $last name, right? And I'm going to save this here. Copy and paste that in there, right? Okay. And so here you can tell that the first two columns have been put together with an underscore, and I've got John Doe here with his unique hash here, Paul Smith, Jane Doe, etc., etc., etc. So what can we see here? The first thing is there's still duplicates. There's still two John Does, the first and the last, and there's still two Jose or Jose Banyas here. One of the things you can notice here is that the second one has been, the spelling is slightly different. If you look back at the input, the spelling here, the first one was accentuated, line number 5, while this one was not accentuated. But if you look at the data here, you will see that these are effectively the same people, okay? All of these data for the two the two Jose Banyas are exactly the same. So why is that the case? Well, just it will happen sometimes that you'll have duplicates in your line lists. And that will happen several times, especially when you merge different line lists from different dates all together. Then you'll have duplicates in there. And one of the things you want to avoid is having two different lines just for the same individual, just because the same individual has been spelled differently. And that will happen typically when you have different accents. So that would be a mistake here in this line list. But the one thing you want to avoid is to end up with two hash keys that will be different, because if you had accentuated characters in one way and not the other way, the hash keys would be effectively completely different. So the fact that hash names here process the data to remove all the accents is actually something useful here, because you end up for these two individuals with the same exact hash key. Now, there is going to be another problem, kind of the opposite problem with John Doe here, because John Doe, we have two John Does here, and you will see that these are different individuals. So let's have a look at the first John Doe here. It was born in 1989, and if you look at the last John Doe here, the date of birth is completely different. And in fact, I'm going to pull this down for you a little bit. You'll see that all the fields here are different. So it's probably not a typo. It probably is just two different individuals that just happen to have the same first name and last name. May not be very likely when you have a small data set, but for large data sets, that kind of duplicates will happen because some first names and some last names are very common. So how do you go about disentangling these two individuals and not having the same hash algorithm, the same hash key, which you have here? Well, one way to come up with unique labels is just to add, say, the date of birth, because the odds that individuals will have the same first name, last name, and date of birth are quite low. So this is what we're going to do here. I'm going to copy paste this and just add the same to the same command line, a new one line list here, dollar date of birth. Okay, control return. Let's evaluate this. Okay, and there, if you have a look at this, you can tell it takes a bit more space now because this is all the labels are longer, right? Okay, so that's better now. So now you can see that the dates of birth have been appended to the first and last name, and the hash obviously all changed because the inputs are different. But importantly, you see that the first one, John Doe here, is different from the last John Doe there, right? You can tell that the different the hashes are effectively very different. Right, so, and the cat is coming to say hi. I think she wants to go out. So she's going to help me with the last bit of this, maybe not, which is about salting. Okay, and then we're nearly done. So I can generate unique hashes there, and typically what you will want to do is just retrieve these labels here and say, these are my labels. You'll save that information maybe somewhere so that you have a correspondence between the labels, the individuals, and their anonymized keys here, which, by the way, we may want to store. So I'm going to say, for instance, lab. I'm going to save this as result, res for result. Okay, control return, and I'm going to say res dollar hash short. These are your short labels here. Okay, so you could retrieve them. They've been converted to a factor here, so you probably would want to save them as characters, but you could basically say lab for your new labels equals as dot character of this. Right, and the reason why these were not characters is there's an evil option in R called strings as factor, which is true by default, and which is called when you create a new data frame, which we do here when we create this input. And there you go, I've got my labels here, and so I could use basically these labels to replace the first two columns of my data set, remove them, and then share the data and export it and send it to my collaborators. But in the first place, there's one last thing I want to basically discuss with you here, and this is salting. So what is salting besides something that's happening in London? Because, well, you can't see that, but there are snowstorms at the moment in London. So besides that kind of salting a hashing algorithm is basically a technique which will prevent you from being a victim of rainbow table attacks, which I discussed very briefly before. So rainbow tables basically are tables of hashes that have been pre-computed for a lot of different input, and then you know that if you see a hash key which matches the one you see in a given data set, it corresponds to the same input. So a rainbow table for first names, last names, and dates of birth will be fairly simple to generate, but it will take a long time and a lot of space. But that is still doable. Okay, somebody who's very determined could very well do that. So how do you avoid that kind of trick? Well, basically one kind of things you can do is just add a pinch of salt to your algorithm, which means you just add a tiny bit of input to your existing input, the first name, the last name, the date of birth, and you just add something else, the pinch of salt. And you don't tell people what it is. So these will have to remain secret amongst your collaborators or within your organization maybe, and maybe you will want to change the salting every now and then as well, but that's going to be part of the policy of your organization. But basically the rationale is take a little bit of input that you add on to all the other inputs without telling anyone except for your collaborators, and then generate the hash keys that way. That means people won't be able to guess what your inputs actually were using a rainbow table, unless they knew exactly what the salt was in the first place. But your collaborators who know what the salt is will be able to reproduce exactly the same labels from the input themselves. So if they have the same data set that also hasn't been anonymized, they can make sure to anonymize it the same way as you, and then you'll have matching labels across different computers and different people. That could be very useful if you think of lab work, for instance, where samples from the lab will give rise to new data sets that will have to be matched across with your line list further down the line. Okay, so how do you sort using hash names? Well, basically the function allows you to do that, and that's a new feature in the new version of Epitrix. By default, salt is null, which means by default the hashing is not salted. But you can basically provide anything as salt. Any R object, in fact, will work. So you can give it a number, you can give a character string, you can give a vector of characters or numbers, or you can even give it a function or whatever kind of input you will want. What's going to happen to this input is it's going to be hashed itself using SHA-1 again, and then the hash key, which will be something akin to this long string of characters and numbers, will be appended to whatever the input will be. So let's have a look at that in practice. I'm just going to copy and paste this here, right? And I'm going to make some space here, and I'm going to say hash salt, equals, and I can give it whatever I want. So I'll just take a vector of numbers from 1 to 10. Okay, it doesn't have to be that, it could be any input I want. And let's have a look at what these will look like this time. If I recall this command line here, Control C, Control V, you'll see that the things that I had before, my former labels here, are different from the new hashes here. And this is because it's been salted. Okay, and remember, if you change a tiny bit with using a good hashing algorithm, if you change the input a tiny bit, the output will be completely different. So this is what we see here. In fact, we actually changed the input quite a bit as well. So if I wanted to use labels that are fairly safe, I would just need to remember that I used these vector of numbers from 1 to 10 as salt, and then I could say my labels equal this, like copy and paste this here. I struggle a little bit. I'm going to copy paste that here, right? And my new labels will be these character strings here. Okay, I could take longer ones if I had a very large data set and I really want to make sure that two different individuals won't have the same label. I could just take a few more characters, maybe 8 or all the way up to 10. And once you have this, well, basically you'll be able to just concatenate this with your previous data set. So I could say my new data set, let's call it df for data frame, equals cbind of my labels, so labels equals lab, and then my original line list, but nope, not line list. Okay, but I am going to remove the first and second column this time, and to do that I will say minus C1 2, which indicates that I want to remove the first and the second column. And if I have a look at this, that should do the trick. df is here, and there you go. I removed the first name and the last name. I kept the date of birth because that could be useful information. This time I've got my labels here, and I could just save this data set using write.table and save it somewhere else. So we can do that right now, write.evencsv for instance, and say, so df is the name, file equals new dataset.csv, and I think that should be enough. Let's have a look at what this did. If I go back to my folder, new dataset is here. It's just a CSV file. I can open it up using Excel as well. And there you go. Okay, I've got this first column that's pointless. I could remove it. But this time around, I have my different labels here and all the rest of the information. This is an anonymized dataset, and I could share it safely with my collaborators. And I think that about wraps it up. So this was how to anonymize datasets using epitrix. Feel free to post your comments and questions further down, or be in touch if you want to ask anything about this, or if you have any comments on this. Thanks, and I'll see you next time, guys.